get this started. Okay, guys, so week 4 coming into this, so thank you guys for hanging in there with me. This week we're gonna divert a little bit away from DVX administration and start looking at upgrade scenarios and expanding your cluster and some of the considerations that need to be taken around that. And then also as you're thinking about potentially sizing DVX for maybe a secondary environment or things like that, I figured that it would be a good time to take you through not just the sizing exercises and kind of what we do as Datrium SEs, but also what you can do in your own environment as you're starting to do growth planning. A lot of my customer set, so again, a lot of you guys, I met you 2 and 3 years ago. And so, you know, you guys are starting to come up to your first renewals. You're starting to come up to that point where maybe it's time to add another data node. I also noticed after, you know, a couple of weeks ago when we did the protection groups training, that suddenly we got a bunch of support tickets about PGs causing high space utilization. So I just kind of want to talk through all that with you guys so that you can kind of balance what the future looks like, and then if you do decide to upgrade data nodes, you know, what that process looks like. The other thing to talk about in this that we're going to go through is N+1 or data node fault tolerance, which is a new feature that we introduced in the 5.1 firmware, which gives you the ability to group multiple data nodes together to sustain the failure of an entire data node. So as it stands today, we can sustain a lot of hardware failure within the data node pool. However, if an entire data node fails, you will lose your data node pool. And we've had multiple, I'm looking at names in the attendee list, and I know specific people who have had that problem. So this is a way around that. And then again, for those of you who just need higher uptime, higher resiliency, maybe that's something that a business ask is generating. You know, it's just an easy way for you to add another data node, check the box, say, you know, enable DNFT, and go from there. So with all that in mind, the first thing that I want to do is I want to take you guys through data node sizing, because I think it's important to understand the capacities, because as you all know, we have a 48 terabyte data node, we have a 120 terabyte data node, and then we also have a flash data node. But how do we actually figure out how much of that is usable? So this is a sizing calculator that was created by Jeff Parker, our field CTO, and then Brian Bernsey, who's our cloud, our VMC SME, and I kind of took it from Jeff and made some tweaks, and we got a pretty good sizer now. But what this gives me the ability to do is on the left-hand side here, you can see that on each of these, I have traditional data node configs. So basically, you know, without N+1, and then on the right-hand side, I've got all the I've got all the configs with data node fault tolerance. The second thing that you'll notice is that I've got a warning versus a usable. So let's talk about that. We have within the DVX, we have a warning state that kicks in at around 75%, and depending on oops. Can you hear me now? Okay. Okay. All right. Looks like Steve, you're just having some trouble with audio, but others can hear me. So okay. Okay. So on the left-hand side, again, we've got warning, and then on the right-hand side, we've got the usable. So at around 75%. With a single data node, and that number creeps up a little bit as you add more data nodes. And again, that's just due to our erasure coding and our space reclamation kind of changing where we think the warnings are depending on how much usable space there is, and then of course how many disks are in the pool. But you can see on the left-hand side here is the warning size. As Datrium SEs, this is what we always size for. We always size for warning. We kind of don't care about usable. And the reason that we size for warning and not usable is A, when we do a new installation, right? The first thing I don't want is I don't want to put a new system in for you and you immediately come back and go, hey, Cam, why is this like 80% full? And it's like, well, because we did the sales guy thing of we sold you the capacity you could afford, not the capacity you needed, right? So that's always the first thing. We always size for warning. The second thing is that at the 75% mark, when we give you warning, it's just that it's a warning. It shows up in the GUI. It shows up in ASUP. You probably get a ticket from it, right? If you've got email alerts configured, you'll get an email alert. When we go above that, there's two more spots. It's about 80 to 85% is the first spot where we stop all incoming replication. So we give you a little bit of a buffer, and then again, that threshold changes depending on how many data nodes you have in the cluster. And if you want to know the specific capacities, you can bust out the user manual, and it'll give you the exact capacities for how many data nodes you have in the cluster and where those thresholds are. But it's about 80 to 85%. We stop inbound replication. And the idea there is that you can keep backing up locally, but we don't want an inbound replication to fill your data node up and put you in a read-only mode. So we stop, again, 80, 85%, we stop the inbound replication. The next threshold is about 90%, and it varies between about 90 and 97%, again, depending on how many data nodes you have in the cluster. And that's when we stop all snapshot activities. So not only are we stopping your inbound replication, but now we're stopping snapshots. So again, at 85%, you can actually still snapshot and you can still replicate outbound. But once you get above that 90% threshold and you get into that kind of last space, we disable the backups because again, it's that one last ditch effort to say, we don't want our process to be the reason that you went offline. So it kind of takes that risk off Datrium, but at the same point, again, it's kind of saving you from yourself. And then as you have to do your business justification to say, why do I need another data node? It's like, well, because our backup stopped working because we ran out of space. So unless you don't want backups, you need another data node, right? So that's that. We also can plan into this calculator what we think the data efficiency is. 2.89%, which is the default in this calculator. That's our customer average. So we pull a weekly report out of ASUP, and we look at the data node average data reduction across all of our customers. There's a few people that we throw out completely from that report. One is basically is a television station up in Nebraska that uses us for a bunch of media storage, and they're getting like 1.2 to 1. And they've got a really large data set. So they're kind of a weird use case where we throw that one out because we know, hey, that's a weird outlier use case. And then there's two that are both universities that have like 1,600 VDI seats at one and 3,500 VDI seats at another. They're all non-persistent desktops. They have no user profile disks because the user profile disks live on outside storage. One is Isilon and the other one I think is living on Cumulo. But anyway, they're getting like 300 to 1 on their dedupe. And so again, throwing that number out because we know that it's wrong, right? It's way overinflated. Kind of like our lab environment, if you've ever seen that, right? It shows like 88 to 1 as our dedupe and compression ratio, which obviously is wrong. So 289 to 1, that's the current customer average. We update this every once in a while if it changes significantly. But when I size, I usually size for 2.5 to 1. For you guys, it works really well because you can just go right into the interface and you can see what your 24-hour average is, and you can put your exact 24-hour average in there. You can put your exact 24-hour average in there and get more specific numbers to your environment. So that again helps when you're trying to calculate your capacities. if somebody asks you how much space is this going to give us, well, okay, yeah, with 5 data nodes, maybe 5 of the D12x4s in my cluster, it's 131 terabytes raw at the warning. However, at 2.5 to 1, that's 328, right? Or maybe I'm 2.37, right? And I can change that, and now all the numbers change to be a little bit more accurate to my environment. So again, super helpful when we're trying to size, when we're trying to configure. This is where I use to do this. If you guys need a copy of this spreadsheet, I'm not going to publicly post it. I ask that you do the same. But if you do need this for sizing calculations, just reach out to me, and I'll share a copy with you, no problem. Another thing that you're noticing down here, probably a lot of you have figured out, is that we only support 5 of the flash data nodes in a single cluster. And you're kind of thinking that's really weird. With the D12x4 and with the D12x10, I can support 10 data nodes in the cluster, but the flash data nodes, I can only support 5. What's up with that? Well, the answer is it has to do with the number of disks that are in the erasure code pool. It's a soft limitation on our part, but it does require some pretty heavy uplift within our file system code to extend the EC pool over more disks. And so if we have essentially one version of the code that supports up to 120 disks in the pool, we can use that on the D12x4, the D12x10, and the F24x2s, the flash data nodes, because at the end of the day, they all end up with the same disk. We're just changing the capacity of the disk. So it made it a lot easier. The all flash data nodes having double the number of disks in a single node is why we can only have 5 in a single cluster. Again, I'm looking at the attendee list, and I only see one person on here that has flash data nodes, and we've already been over this. So, so you know who you are, and you know what the limitations are. But yeah, just for those who are maybe considering all flash data nodes in the future, just be aware that there is some capacity limitations in that cluster. And then when we look at data node fault tolerance, so the first thing that you're noticing is that DNFT requires a minimum of 3 data nodes. So the way that that works is you need to have 2 in the cluster, and then we add a 3rd as a fault tolerance. So there is not a way to convert an existing cluster to a DNFT cluster. We are working on that process to give you that ability to convert an existing cluster to a DNFT cluster, but as it stands right now, you only have that option when you're adding a data node. So you need a minimum of 3. And you'll notice that, again, the capacities on the DNFT clusters are a little bit different. It is on a 3-node cluster, on a 3-node cluster, it's slightly less capacity than you would have on a 2-node cluster in regular. And then once you get above 3 nodes, you actually start to get your space back. So it helps out a little bit. It's not quite losing a full data node. And especially we get some efficiencies as we get larger in those clusters. So, for those of you, there are a couple of you on here that have pretty close to max size clusters. If you thought about adding that 9th or 10th node as DNFT, you actually would not see a significant reduction in your space. It would stay roughly the same. But the rules remain the same. It's 10 data nodes total in a cluster, which means that in a DNFT cluster, it's 9 storage nodes with 1 fault tolerance node. So there's not the option to add additional FT nodes as you get larger. It's not like a break-even point where, oh, okay, we've got 6 nodes in the cluster, which now means that we need a second fault tolerance node or anything like that. It's just 1 tolerance node per cluster, which works really well. So it helps for that. The second piece of this that's really helpful is a backup calculator. So we stole data from a few places to create this. The first is we took the first swag of data from Data Domain. So one of the great things about Cesala being our CTO here is that he was CTO at Data Domain and still had all of their their internal data about backup calculations and average change rates and things like that. We kind of updated them based on what we found through ASUP to deliver kind of an average. And so another thing that a lot of you guys will see, especially my newer customers who kind of bought within the last 6 months, one of the things you probably saw in your proposal was that when we did our analysis of what keeping 90 days of backup looks like, this is the calculator that I use to get that from. And so I have the ability to all the same rates that we can do in the GUI, we can put in here. And so if I wanted to do, what I do for most customers, which is I'm going to do hourlies, dailies, and monthlies. So if I'm doing basically I want to do every hour for 1 day, then I want to do dailies for 14 days, then I want to do weeklies for 4 weeks, and then I want to do, oops, not months, weeks, and then monthlies for 3 months. You'll see that I come up with this schedule. So basically I'm doing hourlies, keep them for 24 hours, 14 daily points, then 4 weekly points, then 3 monthly points. And that gets me 90 days of retention, where for the first roughly 45 days, I have at least weekly points. This gets me basically a 1.64 to 1 data increase. So what that means is for every terabyte of data that I have in the data node, I need an additional 640 gigs at that 90-day mark. I need an additional 640 gigs to be able to hold all of that data. And then if you really want it broken out, we have a kind of a cool chart here as well, where it'll graph all that out for you. But this is, again, this is not exact science. It is a calculator. There's a lot of things that go into what determines your real change rate and your actual data footprint. Some people are going to be significantly more than this. Some people are going to be significantly less than this, right? So this is just, it's a swag, but it's a swag with some pretty good data behind it. So again, if you are looking at maybe getting rid of your Commvault, it's coming up for renewal, and you're like, you know what, I think we could just use Datrium and we'll back up to the cloud. This is a really good way to kind of estimate what that's going to cost you for on-premise storage, and then of course what that's going to cost you for cloud-based storage. Okay, so now that we've done that, let's talk about adding data nodes to the cluster. So adding data nodes to the cluster is really, really super simple. And we're going to go through it in the lab. We're going to show you what that looks like. But adding the new data node to the cluster has a few steps, but it can be done online. It can be done during the day, and it does not involve a whole lot of work on your part. So long as you give the right IPs, and so long as you configure your network ports correctly, it goes pretty easy. So I'm gonna go ahead and I'm gonna change my screen to my lab view, and we're gonna go ahead and log in here, and we'll take a look at this. So when we're adding a new data node, the first thing, obviously, we got to take it out of the box and we got to rack it. After you rack it, my personal recommendation is always get the power going, power up those power supplies. A lot of times, depending on how long that data node's been sitting on your dock or how long it sat in our facility waiting to ship, the battery backups that are in those power supplies may be dead. So for those of you who don't know, on the back of our data nodes, so on these power supplies, Behind the power supply, there is essentially a mini UPS. It's just a battery. And then behind that is a cooling unit. So it's kind of an all-in-one field replaceable unit. It's a tray that slides all the way out. When you slide these trays out, and again, you get your battery backup in there. One of the things that it's designed to do is these batteries are designed to run the array for about 10 minutes. And the idea there being that if you lose power, that is enough time to do a clean shutdown of a data node and properly vault the NVDIMM that's in the controllers, which is also why, for those of you who maybe have moved a data node before, you kind of notice that if you didn't do a node shutdown, that you pulled the power out of these and the data node stayed online for a while and you were trying to figure out like what kind of witchcraft is going on, that it's not just shutting down. That's why there is a battery in each of these power supplies. So I always like to rack it, power on the data node, and then do my network cabling, because not only does, again, that give me time to charge the batteries, because if they're below minimum charge, it actually won't boot the data node until the battery's charged to 75%. But once we boot the data node, the other thing that gives me time to do is it does all the post, it does all the hardware check, basically it does its full cold boot cycle, and that can take a while as well. So while I'm cabling up the data node, I usually like to do that. The next thing that I'll do once the data node's online, I've got it cabled, is I'll just plug into one of the controllers. I will cancel out of the, so I'll plug in with a console cable to one of the controllers. I'll cancel out the setup wizard, and then I'll just do a quick DVX show, node show, alarm show, basically just running through some quick health checks, right? Did they ship me a clean data node, or do I have problems with a controller? Did they ship me did they ship me a bad disk? Did they ship me a bad power supply, right? Because again, these QA when they leave the factory, but there's a lot of time between them leaving the factory and them, getting racked into your data center, and things can happen. And I always like to know that before I'm going to add these to a cluster, so that, hey, if I got a call for a part, most of you are in Dallas, or those of you who are not in Dallas have your data centers in Dallas. Well, our parts depot is in Carrollton, right? So pretty much wherever your data center is, it's within about an hour of my parts depot. And so that's why, hey, if we need to get a disk, if we need to get a controller, if we need to do anything, I just have to put in a quick call to support, say, yo, here's my data node serial number, here's the part that I need to replace, and I've got parts in hand, usually about 30 minutes to an hour. Even if I got to go leave the data center, drive over there, pick up the part myself, bring it back, put it in the data node, it makes it really, really easy. So definitely something I like to do there. Once I've got everything cabled, I've got it online, it's all green from my health checks. The next thing that we do is you're going to want to log into the Datrium GUI. Whether you do it through VMware or you do it through the direct management GUI, whatever your preference is, doesn't matter to me. It all works the same way. But as long as you've configured your network ports, so your management port and your 2 data ports, as long as you've configured those correctly, what you should be able to do is come in here and click on the gear. Or if you're on the data nodes tab, you can click add data node. And this is going to go out and it's going to do a zero-conf discovery to find that other data node and allow you to add it to your cluster. So in this case, we have another data node, and we could select it, and then we could click next. And you'll notice that I have the ability to specify my interfaces. It'll tell me what's got link and what doesn't. Again, link and what doesn't. And then I can go ahead and specify the IPs. Once I specify the IPs, that's all I have to do. And I can click the Add Data Node button, and it will go on, and it will start. It'll start the data node. The other thing that you'll notice here is that, again, there is an enabled DNFT. Now, I don't have 3 data nodes in this cluster, so I cannot do that. But this would be where you would enable that. If you were adding your 3rd data node and you wanted to enable data node fault tolerance, or if you've already got 3 data nodes in your cluster, you're adding number 4 for DNFT, this is where I select that. It's the same process after I select it, but this is where I do it. I can also show incompatible devices. This is important for if you're mixing data nodes for some reason, which I would have prevented you from doing. But if for some reason you kind of get outside of my chain and you go directly to a reseller and you buy a data node and you buy the wrong one, these will show up here. In this case, you'll notice that there are a couple all flash data nodes here that are ready to be added to the cluster, but these are incompatible with this data node because this is a spinning disk data node, which is also important to know that the flash and the spinning cannot be mixed. And on top of that, the sizes of the spinning cannot be mixed. So if you have 48s today, you have to stay with 48s. If you have 120s, you have to stay with 120s. If you have flash, you have to stay with flash. The versions of the data nodes don't matter. So if you have a D12x4, you've got a D12x4B, and we ship you a D12x4C, all of those will work together harmoniously just fine. If you have an F12, or sorry, if you got an F24x2B and we ship you an F24x2D, again, same thing, they work in the cluster, they're harmonious. The revisions, the A, B, C, D, refers to the rev of the controller that is in that data node. And we are end-of-lifing the A and the B controllers as of October this year. They will have support until October of 2024. Yes, October 2024 is end of support date on those. October 2021 is end of feature release. And so what we mean by that is that in 2021, we have some slated features that need the increased amount of RAM that's in the data node controllers, and that's really the only difference between the B, C, and D. The A and the B have a different CPU, so the Bs actually have a little bit more CPU than the As. But B, C, D have the same CPU. It's just the amount of RAM that they have. The Cs and the Ds have more RAM. So that's that was that. And we have some features planned that are going to need that. And that's why we're end of lifing the A's and the A and the Bs. If you have a B node, it's a very, very simple controller swap because it's the same chassis. The B, C, and D nodes are all the Seagate's. They're the Xyratex Daytona chassis. The A's are the Talladega chassis. So different controllers, which is why the A's can't just do a controller upgrade. A and B EOL dates are October. So end of life is, or I should say, end of sale is now. End of life is October. End of this year. End of support is 2024. As far as the controller upgrade process goes, Chris, it's pretty simple. It's you remove the passive controller, you replace it with a new active controller. I'm sorry, you replace it with a new generation controller. So in your case, you'd be going from Bs to Cs. So you pull out a B controller, you put in the C controller, and then you do a nodes failover. It'll fail over to the new controller, and then same thing, we pull the B controller out and we do the C swap. If that is something actually you guys should take offline with me, and we're going to get Josh Kokos and Martin involved on that, just given the number of data nodes you guys have and kind of your sensitivity around downtime. So definitely let's follow up on that. But yeah, there for everyone, again, just remember October 2021. Your A and B nodes will continue to function the same. There's no changes planned. There's no feature incompatibility. There's nothing. Past 2021, you will still be able to use them. You'll still be able to even upgrade to new firmwares. There are just certain features that you won't be able to enable on an A and a B node until you upgrade them. But again, those nodes will be able to continue to operate within the cluster until you upgrade them. So again, for those of you who have A nodes, so Altair, Panda Energy, you know, basically my year one customers. You guys, we are going to be talking to you directly later this year on the process to replace those A's, because it is a full chassis swap. But for my B, C, and D node customers, you guys basically, we're going to handle those at your support renewals. So sit tight, nothing to worry about for right now, but we'll be contacting you individually when your support renewal comes up to go through what the process is on getting those nodes upgraded. So pretty easy stuff. Okay, so now let's say that I have my data node added to my cluster, and it's adding. So what's next, right? So the first thing that we're going to notice is under DVX system, if I go to real time here, you would notice immediately that your durable capacity has increased. It has sucked in the capacity of the new data node. It's available right away. And the same thing goes for VMware. VMware will see that the new capacity is available instantaneously. And that's one of the benefits of erasure coding, is that we don't have to do that RAID expansion that you would normally have to do with a new shelf. The capacities are available instantaneously. So if you are one of those people who's hanging out at 95%, you're hoping and praying that your purchase order is going to get approved before somebody decides to upload all their personal files to the company, or personal pictures to the company drive. It gives you that kind of instant relief valve, which is really nice. On the background, what are we doing during that data node add? So the first thing that we do before the capacity becomes available is we up or downgrade the controllers on the data node to match what your current cluster is. So they will always add with the correct firmware versions. And again, before we add the node, before we add capacity, before we do any of that, there's always a firmware upgrade that happens, so that you're always matched. Once the firmware upgrade is complete, we've added the data node to the cluster, and we've expanded the pool. The next thing that happens is a data rebalance. That happens in the background, and depending on how much data you have and how active your system is, depends on how much time that's going to take. Empty data nodes usually rebalance within a couple minutes. So if you've got a very small system, if you're standing up a new cluster, the rebalance happens very, very rapidly. If you have a very large system and you've got a lot going on, that rebalance might take a couple days. So it really just depends. We do the rebalance on the same priority that we do space reclamation. So it does use the host CPUs to do the rebalance and the validation of the data. Rebalances that data evenly over all the data nodes. And but again, it's the lowest priority task in our stack. And so application IO will always take precedence over a rebalance. So again, in certain cases, if you're adding 3 nodes at the same time and you got a really busy system, you might need to plan a week for those data nodes to add to your cluster. The second thing to know is that you can only add 1 node at a time, because it does need to do a full rebalance before you can add another data node. So just keep that in mind. Again, back to, if you're adding multiple data nodes for some planned expansion, maybe you're doing an acquisition and you're about to suck in all the VMs of your new company that you're acquiring, and you need some new data nodes to do that. Just again, plan that you might not be able to add them all on the same day. So just kind of slow roll that. Once the rebalance is complete, again, the data node lives in the cluster. Everything's great, and you would see the multiple data nodes show up on the data nodes tab. They will all show up individually by serial number, so that on this data nodes tab, you can go look at the individual data nodes and the hardware statuses on those individual nodes. Same thing on network. Oops, not protection. Same thing on network. Each of those nodes will show up in network, so that you can see the interface IPs on those data nodes. One last piece to really consider when you are adding data nodes. We do, and we actually, thank you, Maxor, for finding this. And now we have an RFE in, and it should be in the next version of our feature check, or not feature check, our environmental check. But we check all of the interfaces on our side, but we don't check the interfaces on the hosts. So if you have a duplicate IP, we check through all of the known interfaces within the DVX cluster. We don't double check your VMs, and we don't double check what's going on with your VM kernel ports. So if you accidentally put in the wrong data node IP address on the data side, or even on the management side, you potentially will cause an IP conflict, which will definitely take down a portion of your network. It can be changed. It's an easy fix, but again, it does require downtime of the pool because you potentially cause an all paths down issue when you change that IP address. Again, we discovered that adding data nodes for a customer who had good IPs and everything was great, and it turned out that there were some conflicts, and so we ran into an issue there, and it was discovered that in our check when we do the data node add, we're kind of focusing on the Datrium side. We're not really focusing on the host side. So just be aware of that. Really double check your IPs, and then if you're on 5.1.5 when it comes out, it'll be included in the check. But if you're on an older firmware version, just ping things, log into the data node, log into an existing data node and ping, and just make sure that the IPs are open and available. Because the other thing is, even if you've got really good documentation, or if you've got something like info blocks where it's going, or SolarWinds where it's going out and it's checking all the IPs in your networks and keeping those lists up to date for you. Sometimes the tools aren't always accurate. So again, just never hurts to go through and double check that. Okay. So that's data node adds. Data node adds are, again, they're super simple. The only times that I've seen data node adds take down clusters or cause problems, one is IP conflicts, which we just went through. And number two was we used to have a bug in the 4 firmware, so the 4.0 and the 4.1 firmware, where adding a data node beyond 4 would cause a problem in the cluster. It's a known issue. There's a TSB about it, and you can read that if you really want. The fix for it is just upgrade to 5.0 or 5.1. That's really kind of the simplest thing. And at this point, 5.0 and 5.1 are our recommended supported firmwares. The difference being that, hey, if you need the DR as a service or control shift capabilities, go to 5.1. If you need DNFT, go to 5.1. If you don't need either of those things quite yet, you can stay on 5.0.1.3. Totally doable, but there are some significant back-end improvements in the 5.0 versus 4 and 4.1, and so we definitely recommend getting onto 5.0.1.3. Okay. So now that we've talked about data nodes, let's talk about hosts. So host adds, again, super simple. If you need to add a host to a cluster, come to the host tab, hit add host. This does need to be done through the VMware vCenter server. You can do this, you can do this manually if you want to, through the ESX CLI on the individual host. So if you've got maybe a standalone ESX host, it is running on a free license, or maybe you're running on it, you're running it on like a vMug Advantage license, something like that. It's not part of your cluster, but you want to add it to your Datrium for storage. You can do that through ESX CLI, and those commands can be found in the user guide. But if you're going to add a host under normal operation, again, it's here. Couple things to note. One, we use the VMware inventory service for this. So if you have linked vCenters, we're going to see all of your hosts. So just be aware that that if you've got linked vCenters and you've got a bunch of hosts in your vCenters, we're going to see all of them, and definitely check it out here to make sure that you're going to the right one. The other thing that we'll note, if you've got multiple DVX clusters in the same data center, or if a host is already added to the existing DVX cluster, it will tell you that, hey, I'm already part of a DVX cluster. If you've got a host that was maybe attached to an old DVX cluster, it's still got the Datrium VIB installed, and maybe it's still looking for that old cluster. Again, it'll tell you that here, that, hey, I've got your software installed, but I'm still looking at the old cluster. The easiest way to do that is just to do the ESX CLI VIB uninstall, to pull the old system's VIB out and to put the new one in. There is a way to do basically a blank install and a VIB conversion, but to be completely honest with you, it's so much faster to just uninstall and reinstall the VIB than it is to do that conversion process. And that's why we do it. We do it like this, is just to say, hey, pull it out and then let us reinstall it through here, right? So this does need to be done through VMware unless you're going to do it manually. And again, it's because we use the VMware inventory service, and then we use the vSphere Update Manager API to actually push that VIB out. So once I've got hosts added, again, hosts, once they are added, they will get added to the default data store. They will have their SSDs added. But what if I create a new data store? Or what if I need to unmount an existing data store? Or what if I need to take an existing host and add some flash to it? So if I go directly to the host, let's walk through that. So flash is the easiest one. All I got to do is I go to the flash tab. I can see all my flash devices, and I'm going to click add new device. Now in this case, this host just has 2 SSDs. I could also look at invalid devices. Again, it's saying, hey, I do actually see that you've got an NVMe drive in here that we're running ESXi off of, but it's too small. So it's showing it as invalid. If you remember back to kind of my first talk on a lot of this, the minimum device size that we support is 480 gigs. So it's got to be 400 usable gigs of SSD capacity to be included in a DVX cluster. So 32 gigs, well below it, it's not usable. And again, if you've got a device that is it's either too slow, maybe it's a SATA 3 SSD instead of a SATA 6 SSD, we'll kick it back as being non-supported. Maybe it's got a partition on it. We'll kick it back as having a partition on it. You have the ability, in that case, you do actually have the ability to kick the partition off of it. So we'll wipe the disk and then include it. But it'll let you know that. And then also, when we do our test for devices, we do a read-write test against each device. It's a little speed test just to make sure that the device meets our spec. But what it also ensures is that we can read and write to it, so that if you add an SSD and for whatever reason it's like in a read-only mode, it'll catch that before we try to add it. We can also remove SSDs. So if you're maybe someone who has like say you've got an R630 and it's got the 6-disk configuration in it, where it's basically got the 6 2.5 inch drives, and then it's got 4 of the NVMe hot add slots. And let's say that you need to do a flash upgrade because maybe you're out of cache, but you don't have any more slots to add SSDs to the front of your server. So one of the things you can do is you can tell it to remove an existing SSD, and I can go ahead and I can do that here, and it'll pull that SSD out, and it will move as much of the data off of that SSD as we can onto the other SSD. So in this host's case, right, we have a ton of flash overhead, so it would be able to move all of its active data. But if you don't, again, no big deal. We'll either use Pure Cache or we'll just read directly from the data node. You'd pull that SSD out, you would drop new SSDs in, and then again, come back in here, you'd select your new SSDs, and you replace them. It is really important if you're going to do any kind of flash swap like that, where you're pulling old SSDs out and putting new SSDs in. It is very important that you remove the old SSD first and then add the new SSD. I know it sounds pedantic, but there have been a couple cases where we've had bugs where basically there will be phantom failed devices, and it's like, well, duh, it's a failed device, it's not in the server anymore, we're not using it anymore. But still, if you pull it out first, it'll remove that device from configuration. It saves you from that. So it's one extra step, but it saves you some headache in the future. The second thing to think about is that if you are pulling these SSDs out because you're replacing SSDs, or maybe you're upgrading to NVMe and you're going to reuse these SSDs in new Datrium servers, just be aware that these will retain their Datrium partitions on them. So removing an SSD does not wipe it. You will still need to do some sort of a secure wipe on that SSD or a reset before you can use it in a new host. If you put that SSD into a new new system with the DVX VIB on it, it'll pick it up as a Datrium device and add it automatically. So kind of cool upside is that you'll have some pre-seeded data on that host, but the downside is, again, we'd really prefer that you wipe them clean and add them like that. So that's adding SSD. Some thoughts around adding SSDs. The first, they do not need to be the same size. 480 is the minimum, 10 terabytes is the maximum. Pick something in between there, whatever works for you, add them up. If I start with 192s and I need to add a single 384, no problem. Is there a performance advantage to adding more SSDs? Yes, there is a slight advantage up to 4 disks. Beyond 4 disks, no advantage, okay? NVMe is actually 2 disks, and that has nothing to do with us. It's with how ESX 6.7, well, basically 6.0 to 6.7 handle the NVMe device driver. There's a bottleneck in the NVMe device driver in ESX that basically, if we put 2 NVMe devices in here, we will max out what ESX can do in terms of I/O and throughput. Adding additional NVMe devices gets you more capacity. It doesn't get you any more performance. So SATA SAS SSDs, 4 is kind of the magic number. Anything beyond that, you're getting extra cache. You're not getting extra performance. And of course, don't lopside your cache. And what I mean by that is if I have 2 192s and I add a 7.6 terabyte SSD, well, yeah, fine, that works. And that's an okay configuration. We're not going to spit that back. But what happens if that 7.6 fails? Well, the majority of your cache on that host just failed. And so now you're in a very, very strong constraint position. So your better bet, if you needed 7.6, would be to add 2 384s, right? So it's a little bit more expensive than adding a single drive, but it prevents a single cache disk failing from removing more than a quarter of your available cache on that host. So just keep that in mind. The last thing, can I mix NVMe with other types, right? So if I start with NVMe drives, maybe I start with like 2 192s or I start with like 2 960s because I have a small SQL workload, but it needs really high performance. Can I add more in the future? Answer is yes. In fact, I have a customer on here right now who, if they want to raise their hand in chat, they're welcome to do this. But we started their entire environment on NVMe. And as they needed more space, we didn't have space to put NVMe cards in their 1U servers. And so they just started adding SATA SSDs. And basically the way that it works, we don't tier. So we don't understand the difference between various flash devices. We treat flash as flash as flash. But what we do is we always put the blocks into the device that responds first. Well, your NVMe devices are always going to respond before a SATA SSD as long as they have available blocks. They're just faster, right? So kind of on its own, it will always prefer the NVMe disks over the traditional SATA SSDs. But again, as you fill that up, we don't have a way to say this VMDK always pins to these flash devices. So just also keep that in mind, right? Okay. Pros, cons of combined NVMe versus so yeah, so I just got a PM. Are there any pros, cons to combining the NVMe and the SSD? The pro is being able to expand a system without having to without having to replace NVMe cards, right? Replacing NVMe cards is expensive, and it's also, you know, it requires you physically taking apart your server, unless you're doing NVMe hot add in the front of the server. So if you've got U.2 devices that you can do to the front, great. But if you don't, which is the majority of everybody on this call, you would need to crack open a server and add a card. So that's some additional downtime. So adding SATA SSDs in front of it obviously gives you that ability to add cache without having to crack open your server, so you can keep your uptime. The con is that I can't pin workloads to SSDs. So if I have a SQL workload, so maybe if I'm using my host as mixed-use clusters, and I've got, you know, my SQL VMs are floating around, and my, you know, VDI VMs are floating around, and I've got some, you know, regular just IIS or Apache servers floating around or whatever. I don't have a way to guarantee that that SQL server is always going to land in NVMe on a particular host, right? So you might kick out some SQL blocks to your SATA tier in preference for the Apache blocks because they were there first, right? So that's kind of the con, is that we don't have the ability to pin things to flash tiers. So again, if that's something you need, we strongly recommend just have a host that is solely NVMe. But if you want to start with NVMe and then, you know, say, you know what, I'm going to grab a little bit of extra SATA SSD because I've got a little bit of a cache overage that I need to handle, it's totally fine, right? And again, if you want to deeper dive that, please email me and let's talk about your specific environment and let's go through that. So now that I've got additional flash added or removed from a host, the next thing that I can do is under host config, right? I can go to mount, unmount Datastore. So this again gives me that ability if I'm using multiple data stores, and we talked about how sometimes it's really helpful to separate if I've got two sites replicating to each other. At each site, it's helpful to create a second data store called like DR Datastore or something like that, so that when I recover VMs from my partner site, I recover them into a data store that's for, you know, that's for that particular site, right? So it makes it easy for me to figure out, hey, these VMs are part of my other site, they're not part of this site, or, you know, same thing, if I'm spinning up a test environment and I want to clone a bunch of VMs, maybe it makes sense to have a clone data store. Maybe if I've got an environment where I am isolating SQL to two hosts. So we did this at Altair, and this was for SQL licensing constraints. So what we did was we not only we isolated our SQL VMs to a bunch of hosts, and we used a VMware DRS affinity rule to do that. But then also have the ability to put those in a data store that will only mount to those hosts. And that was basically what Microsoft needed to prove that we were not abusing the licensing, and that we truly were only using SQL on a couple hosts, right? I've got customers as well, Oracle RAC, same thing, right? Oracle licensing is even more strict than SQL licensing. And so restricting VMs to hosts, and then additionally restricting them to data stores that are only mounted to certain hosts has helped there. So I can mount data stores or unmount them here. Now, something to also note, data stores don't mount automatically. So when you add a new data store, you do have to come to each host and you have to mount it. So just be aware of that. Now, on a reboot, a host will automatically mount all the data stores that were mounted at the time of the reboot. So it's not like you have to come in here every time. But that also means that if you decide to unmount a data store from a host, and then you reboot it, again, it's not just going to automatically re-add that data store. So you do need to manage these on a per host basis. Okay. And then the last thing under host management, this is just talking about, again, replication networks and dedicating a replication network, if that makes sense to you. So we don't really need to talk about that. And then, of course, flash sharing. So this is another interesting thing. If you have, again, if you have those NVMe hosts that you really only want your NVMe or your 3D XPoint or your Intel ruler or your persistent DIMM, whatever advanced flash technology that you spent a bunch of money on, if you only want those to be used by those workloads and nobody else, one thing you can do is you can come in here and you can uncheck flash sharing, and that host will no longer participate in pure cache. Now, it will still utilize pure cache, so if it loses its local SSDs, it will still go to the rest of the cluster, the rest of the cluster with the bowl of porridge and going, please, sir, may I have some more? But if somebody comes to it asking for SSD space, it'll go, I'm sorry, I don't share SSD, right? So if you need to social distance some hosts, this is the way to do it. Okay. So that is host adds, data node adds, expanding your clusters. Again, maximum hosts on a single DVX cluster is 128. Those hosts do not all need to be in the same VMware HA cluster. They also don't even need to be in the same vCenter. So if you have a single data node that's attached to multiple vCenters, or a single DN cluster that's attached to multiple vCenters, we can have multiple hosts from multiple vCenters all talking to the same DN. So again, for those of you who have split like your Horizon environments out, and Horizon has its own vCenter, its own host, it's its own little entity, hey, no problem. You can use the same vCenter, DVX cluster to run your Horizon and your prod cluster. Same thing, if you've got your lab environment and you're using your vMug Advantage licensing in your lab environment, and you want to connect that to Datrium because you want the performance, right? No problem, we can do that. So it's 128 hosts. Each data node can support up to 32 hosts. So basically, to get 128, you need to have a minimum of 4 data nodes in your cluster to do that. I would expect that anybody who is going to be trying to do 128 hosts probably has close to max size data node cluster anyway, just because that would be a lot of data, unless you're doing crazy amounts of VDI where you have no data but you need a ton of compute. And then again, we monitor your host write performance, and that's where the scale up potential comes into play. So just again, as you're looking to add hosts, make sure you're coming into scale up potential and validating that you actually can add hosts. There are some of you that are going to find that your one host cluster, or sorry, your one DN cluster will not support 32 hosts. You've got too much write throughput, or you've got too much replication going on, and it's going to tell you you can only scale up 10 or 12 or some, maybe 2, right? There are some of you who are going to have a 2-host cluster that are only going to see 40 available hosts for scale up instead of all 64. So just be cognizant of that. And again, our lab, given what we've got going on in the lab, the kind of workloads that we have here, we know that we can scale up 1 host before we're going to start to create write latency issues on that data node. So just kind of be cognizant of that as you're thinking about upgrading. The other thing to think about is that hosts can only be a member of a single DVX cluster. So we've had a couple customers recently who have wanted to do a 120 migration. So they want to come from their 48s to their 120s. Ran into a couple issues, right? The first is that you need to kick a couple hosts out of your existing cluster. So empty them out, kick them out, put them on the new 120s, and then you need to start doing vMotions. Depending on your network resources, depending on how busy your hosts are, and then also depending on how much flash you have in those hosts and how hydrated those VMs are within that flash is going to determine how fast you can actually move those VMs. Now, there are some ways that we can help accelerate that. So we could actually use replication within the same data center to do a failover, but that requires downtime, right? Because you gotta shut down a VM, do a snap, replicate the snap, bring it up on the new cluster, bring it up. Unfortunately, the customers that we had that needed the 120s could not afford the downtime. We had to do it live, and we found some limitations. So just be aware that if you're looking to change from the 48s to the 120s, that potentially there are some migration challenges that you're going to need to consider. And again, that's let's sit down, let's have a conversation about how much data you're moving, what workloads can be done offline versus online, and then kind of what your strategy is, because there are a lot of really positive reasons to move to the 120s to have the extra space, but there's not a direct way to be able to do a cluster change kind of midway. It's kind of like changing the engines on the airplane as you're flying cross country. Sure, you can do it, but there's some planning that needs to go into it. So just be cognizant of that. The last thing that I want to cover is, of course, Bmc Sizing Considerations. Kind of running out of time today, so we're not going to go too far into that. But there are multiple calculators online for Bmc sizing. We have our own as well. Just know that Datrium uses the i3 metal instances. We have R5s, but I will tell you the pricing that we have on the R5 is not great. The other thing that I will tell you candidly is that, and you can find this information directly from Amazon and directly from VMware as well, but the performance of the R5s on their storage is horrendous. And it's really, that's what happens when you take a flash EBS store and you make it pretend to be an NVMe device. So their performance is not that great. They're really big, and because of that, they're really expensive. So if you want to do any sizing for what size workload you would need in a DR failover, if you're going to do from on-prem to cloud, the on-prem piece is really easy. Just come into your data node real time here, look at your capacity, whatever your used capacity is between your total capacity between your active data set and your snap store. That's going to be your cloud DVX capacity. Just give me that number, and that's super simple. If you've got multiple sites replicating to a single cloud DVX, probably going to get a little bit of extra deduping compression out of that. Not much. So just give me those 2 sites, and I can get you a number back. But then when you're thinking about how many hosts am I going to need to run my full workload, what portion of my workload can I run on the vSAN versus leaving it in cloud DVX, things like that. That's where it gets a little bit more specific to each customer. So again, just go ahead and reach out to me, let me know, and we'll have that conversation, and I can share those sizing tools that we have. So with that, I want to say thank you to everybody for hanging in there another week with me. As of right now, I don't have a topic for next week. And so I'm going to try to think up something. But if you guys have anything specific you want to see, anything specific that you want to learn, if you want to like really deep dive the read-write path, like anything like that, please shoot me an email, let me know, and we'll do that. Additionally, I think next week is the last scheduled session that we have for these. So if this has been really useful to you and you want to keep kind of like a weekly cadence, maybe open this up a little bit more, make it a little bit more collaborative, and have it be more between actual users instead of kind of it being a I talk and you listen type thing, let me know that as well. And we'll get more of kind of like a user forum going, where maybe we can do like 15-20 minute presentations of people talking about something cool they did with their environment, just to kind of trade ideas and get some collaboration going. So with that, I'm going to get this week's upload done. I also need to do last week's upload. That's been sitting in my queue in Adobe Premiere, and I just have not gotten around to actually exporting that out to YouTube. So I need to do that. But with that, thanks guys. And yeah, I'm going to hang out and chat for a few more minutes. But with that, thanks again for the time.